Good morning, students. Today, our topic in chemistry is water. What did I say? Water. Yes, you heard me right. Water. And we have three objectives. You should be able to know what water is and the types of water. The second one, identify how to treat water for town use. Then explain hardness of water and the types. These are the three objectives at the end of this class. So get your writing materials ready. Let's go. What did you see in that picture? Water, isn't it? Now, what is water? Water is a substance of the chemical elements hydrogen and oxygen and existing in gaseous, liquid and solid states. That is what water is. The substance of the chemical elements hydrogen and oxygen and existing in gaseous, liquid and solid states. That is water. We have types of water, and there are two types of water. They are natural and treated water. These are the two types of water. Natural and treated water. Natural water includes rainwater, spring water, well water, river water, and sea water. Listen attentively. Natural water, they include rainwater, spring water, well water, river water, and sea water. These are natural water. Rainwater is the purest form of natural water because it is formed as a result of the condensation of water vapor in the atmosphere. Once water gets to the atmosphere, it will condense and fall back as rain. You know now. Once in this particular place where water will dry up, sun dries water up here and take it up to the atmosphere where condensation will take place. Water will fall back again as rain. And that rainwater is the purest form of what? Water. Now, the other type of water is treated water. Treated water is usually prepared for special purposes. Examples of treated water are distilled water, pipe-borne water, and chlorinated water. These are the examples of treated water. Distilled water is chemically pure water. It is prepared by condensing steam or passing water through an ion exchange resin column. That is how distilled water is prepared. By condensing steam or passing water through an ion exchange resin column. Distilled water is used in the laboratory for preparing reagents and doing analytical work. Yes, we use distilled water for preparing reagents and doing analytical work. You all have seen distilled water in the lab now. It is also used in the preparation of drugs, car batteries, and for certain industrial processes. These are the uses of distilled water. Okay? Make sure you write them down. Structure of water. Structure of water. Water is an example of molecular substance. All substances in this class are liquids at room temperature, and virtually all liquids are molecular in nature. They have relatively low melting and boiling point. virtually below 300 degrees Celsius. In terms of composition, water is regarded as an oxide of hydrogen. When dry hydrogen gas is ignited in air, it burns with a pale blue flame to give steam, which will condense on contact with any cold surface to form water. What is the structure of water? That is it, molecular. Okay, molecular. And water can be formed when dry hydrogen gas is ignited in air. It will burn with a pale blue flame to give you steam, and once it gets in contact with any cold surface, it will form water. Are you there? Yeah. Okay. Treatment of water for town use. Treatment of water for town use. Water for domestic use is prepared in a water treatment plant. Now, what do we even mean by treatment of water for town use? The water all these tankers distribute to you, which you use to cook, wash, do laundry, and chores. How is it treated? The tank water, I mean, how is it treated? That is what we are going to learn now. How the water in the tank you guys are using are treated. Now, water for domestic use is prepared in a water treatment plant. This water is usually germ-free but contains mineral salts. Yes, that tank water contains mineral salts. The water is purified by various methods, which include, listen attentively, water is purified by various methods, which include aeration, coagulation, sedimentation, filtration, and disinfection. These are the methods of purifying water: aeration, coagulation, sedimentation, filtration, and disinfection. Now let's look at them. Treatment of water is done in the following ways. Pay attention. Don't allow anything to distract you. The untreated water from source, like rainfall, rivers, and lakes, is aerated by stirring up or letting it fall down steps to let air or oxygen mix with it. What does it mean? Once they get water, either from rainfall or rivers, dirty water, lakes, they will do what? They will stir the water up, or they will just allow the water to be falling, step down, to allow air to pass or mix with the water. What is the essence? It will help to remove ions, iron 3 ions, and other volatile chemicals such as hydrogen sulfide, carbon 4 oxide, and odor from the water. Yes, that is the essence of aerating water, and that is what we call aeration. Stirring water up or letting it fall down steps is what we call aeration, which is the first treatment given to water. And what is the essence? To prevent, or to remove rather, iron 3 ions and other chemicals like hydrogen sulfide, carbon 4 oxide, and odor from the water. The next step, the water is then passed through settling tanks where chemicals like potash alum or sodium aluminate are added to cause coagulation. This is the second method of purifying water, coagulation. They will put potash alum, that's whitish crystal stuff, alum, call it alum. They will put it inside the water. The alum will now collect dirt. They will now clump together and form a ball. Once you put once you put alum inside the water that is dirty, the alum will collect all the data and it will form a lump, ball-like lump. It will now settle down. That is the second method. We call it coagulation. So the water is passed through settling tanks where chemicals like potash alum or sodium aluminate are added to cause what? Coagulation. The impurities clump together to form big particles of dirt which settle down rapidly. That is the second one. Then the third method, which is sedimentation. The water is passed through a filter bed to remove the remaining fine particles of dirt. Yes, sedimentation, separating. The water is passed through a filter bed to remove what? The remaining particles of dirt. That is it. Are you with me? Then the next method, the water is now treated with chemicals like chlorine to kill germs. Other useful chemicals such as iodine and fluorine may be added in the correct amount as food supplements to prevent goiter and tooth decay. The next step is to add chemicals like chlorine to kill the germs, then iodine and fluorine. Iodine, what is the work of iodine? To prevent goiter. What of fluorine? To prevent tooth decay. Now after that, the treated water, which is now clear and free from germs, is stored in a reservoir and distributed to towns and cities via underground pipes for domestic and industrial uses. Yes, that is it. That is the diagram. Once you get your water from the source, which is river, lake, or even rainfall, coagulation, where you put first of all, aeration, you let it fall down steps. Then coagulation, putting alum. After that, sedimentation, where you remove the remaining particles of dirt from the water. After that, you filter. After that, you add your chemicals like chlorine to kill the germs, then iodine and fluorine. Then after that, your water is safe for drinking or use. Okay? Now, the next subtopic is hardness of water. If you have any question, type it down. Hardness of water. What is hardness of water? Water which does not lather readily with soap is called hard water. And this property is known as hardness of water. Have you noticed that some water, if you try using it to wash, before foam will form in that water, your soap might have gotten to half. Yes, water that does not lather with soap is what we call hard water. And the process of water not lathering with soap is what we call hardness of water. What causes this? We have three things, or compounds rather, that causes hardness in water. One is calcium tetraoxosulfate 6. Either calcium tetraoxosulfate 6 or magnesium tetraoxosulfate 6. Both of them causes permanent hardness in water, because we have two types of hardness in water, permanent and temporary. Calcium tetraoxosulfate 6 and magnesium tetraoxosulfate 6 causes permanent hardness in water, while calcium hydrogen trioxocarbonate 4 causes temporary hardness in water. Note it now. Calcium and magnesium tetraoxosulfate 6 causes permanent, while calcium hydrogen trioxocarbonate 4 causes temporary. Okay? Now let's look at the types of hardness. Temporary hardness. This type of hardness is caused by the presence of undissolved calcium hydrogen trioxocarbonate 4, which decomposes on heating. This calcium hydrogen trioxocarbonate 4, once it decomposes, and water flows through it, that water will be hard. How can you remove it? By boiling the water or addition of slaked lime. These are the two ways you can remove temporary hardness: boiling the water and adding slaked lime. Permanent hardness. Permanent hardness can only be removed by using chemicals. It is caused by the presence of calcium or magnesium ions. Permanent hardness, like I said, can only be removed by using what? Chemicals. It is caused by the presence of calcium or magnesium ions in the form of tetroxysulfate 6. And how do you remove it? 1. Distillation. 2. Addition of washing soda. And 3. Addition of caustic soda. These are the 3 ways of removing permanent hardness: distillation, addition of washing soda, and addition of caustic soda. Make sure you are putting this down, putting these things down. Okay? What is water? Identify how water is treated for town use and explain hardness of water, causes and uses. Want to see them? Okay? Do have a wonderful day.